Hello from BUGSENG. What do we have here? We have 5C source code files. Let's have a look at them. The first one is called commentingout.c. Here there is some code, a printf, that is only executed if isadmin is true. But isadmin is false, so the printf will not be executed. Here is another source file, earlyreturn.c, that prints hello world and then exits. Next file is called homoglyph.c. Here I see two functions. What? They have the same name, say hello. How can this program possibly compile? Here we have source file invisible function.c. This is similar in that we see two functions apparently with the same name isadmin. This shouldn't compile either. What's going on here? Finally, here is example stretch string.c. The access level string variable is set to user. The string comparison function strcmp returns 0 when called with two identical strings. As user is identical to user, 0 is returned here, so the printf is not executed. Okay, this was the last example. I have another file here. It is a small script that compiles all the example programs with the GNU GCC compiler. Let me run it. Compilation went fine, and not even a warning was given. But didn't we say two of the programs shouldn't even compile? Anyway, we now have executables. Here they are. For the commenting out example, I loaded the source code into the GNU Nano editor. Isadmin is false, thus the if guard is false, and the printf would not be executed. Let me try. Oh dear, how could the printf be possibly executed? Something is fishy here. Something is happening. And in fact, what we are looking at is an example of a Trojan source attack. If the isadmin test and the closing brace are not outside the comments, they are inside. Let us look at the next example. This is earlyreturn.c, and I have loaded it into VI, which is a very popular editor. As the comment says, the program prints hello world, then a new line, then it exits successfully. Oh, no, nothing was printed. Here, the opposite is happening with respect to the previous example. Return 0 appears to be inside the comment, whereas it is outside. So the return 0 is executed before the printf. Next example, homoglyph.c. So for this one, we wondered how it could possibly compile because we see the two functions called say hello here in a Visual Studio Code buffer in front of our eyes. But imagine that the two say hello functions were in different translation units. We wouldn't be surprised. And we might think one is called, whereas the other one is called. Which one? Let us try. Goodbye world. So here the point is that two letters that are printed the same, Latin H and Cyrillic H, are in fact different. They are called homoglyphs. They are printed the same. So up to now we have seen that the GNU GCC compiler is vulnerable as editors GNU Nano, VI and the Visual Studio Code IDE are vulnerable. Let us continue. The invisible function.c source file is loaded into NetBeans, another popular IDE. Here again, we have two functions whose name look the same. Imagine they are in separate translation units. Am I an admin? I am an admin. Great. Or perhaps not. Here the problems are not due to homoglyphs, but to invisible characters in Unicode. Interesting, right? The last example source code is loaded into Eclipse. Here, strcmp on two identical strings should give 0, which means the printf should not be executed. Let me see. Wow, I am an admin again. So the problem here is that the string literal, that is the second argument to strcmp, is not what you see. It's not user, it's something else. So again, we see how Trojan source code attacks can be successful. We have seen that GNU Nano, VI, Visual Studio Code, NetBeans, and Eclipse, and also the less file browser are vulnerable. But how can we defend ourselves? Let me show you the ECLAIR graphical user interface. I have enabled this new service, B.TROJANSOURCE, and I'm using it to analyze all 5 example programs. Let me start the analysis. Okay, it has completed now. Let me view the analysis results. Here they are. We have 15 violations and they help us understanding what's going on. So let's see the violations in commenting out.c. There are direction reversing Unicode characters here, and this is why in the end the test of isadmin is indeed commented out for the compiler, but it was not for those inspecting the source code. In early return.c, we can see Unicode control characters that cause the return 0 to be outside the comment for the compiler. For the homoglyph example, ECLAIR says, look, this character h can be confused with this other character h. In invisible function.c, ECLAIR is showing us the invisible characters. Finally, on the last example, ECLAIR is showing us there is something fishy inside the string literal, and this is in fact what causes it not to be what it looks like. So yeah, Trojan source code vulnerabilities are no longer a problem with ECLAIR. You can sleep peacefully and simply focus on your projects. Okay, that was it from me today. Feel free to get in touch with our team. I'll leave you the details in the info box below. Thanks for dropping by. See you next time. Bye.